I'll kick us off this evening by saying a big hello, everybody. Thank you so much for joining us tonight. My name is Talia. I'm the Virtual Experiences Coordinator at the Denver Museum of Nature and Science, and I am so excited to get to be your host and moderator for this exciting event this evening, all about volcanoes. Tonight's presentation is a special presentation of our Digital Earth series. Maybe you're familiar with Digital Earth. Normally, this is an event that we present in our planetarium dome, but of course, with the museum currently closed to the public and to its staff, we had to get a little bit creative. But the nice thing about technology is it means that science can happen from anywhere. We can stay curious and stay connected, even while staying distant and staying healthy. And that's exactly what we're here to do tonight. I am joined this evening by two of our experts from the Denver Museum of Nature and Science. I'm going to have them start their video now. We have Ka Chun Yu, Dr. Ka Chun Yu, who is a curator of space science. He is going to be our pilot and guide this evening. Let me help him get his video started, or it looks like he just needs to switch over to it. And we also have Dr. Bob Raynolds, who is a research associate for Earth Sciences. They're going to be your guide on your journey this evening, and we are so looking forward to taking you all around the world, checking out volcanoes, and taking a look at some of the most fearsome mountains that our planet Earth has to offer us. A couple of quick housekeeping items before we get started. First of all, if you haven't already done so, take a moment to type in the chat and say hi. Let us know where you're watching from this evening, how many folks you have with you, maybe if you have any young scientists or maybe any canine or feline friends watching with you tonight. We always love to know who we have in the room with us. So say hi. We love to hear from you, and we love to see your messages coming in. Hi to Arvada. I'm in Wheat Ridge, so maybe we're neighbors. Hi Denver, hi Evergreen, hi Englewood. It is great to see those messages coming in. One quick note about the chat is that we do have a special security feature enabled, which means that your chats are going only to us. So you are not going to see each other's messages this evening. Again, that's an added security feature, but I will be watching all evening. So if you have any questions, if you have any observations you want to make, maybe you know which volcano is in the background behind me right now, you can pop that in the chat at any time. I will be watching and ready to pull these questions to ask our experts live and on camera. Another quick note is that we are going to be showing you some big files this evening. The software that we are going to be using to take you on this journey around the world is large. So there are a few things that you can do to help ensure that you'll be able to see that video feed. Number one is make sure that the device that you are currently watching on is connected to power. That way we can devote a little bit of extra energy to bandwidth rather than to keeping all of those apps running. So that's always a good suggestion. Another thing you can do is kick those other devices off your home network. So reserve a little bit more bandwidth for these big files. And finally, if you are able to watch in the desktop version of Zoom rather than a browser, that's what we always recommend. So those are just a few tips and tricks, but either way, it's going to be a great program, and we're so excited that you have joined us tonight. And one last note, hi, Mom. My mom's watching tonight, so thanks for tuning in, Mom. Always appreciate it. Without any further ado, I'm going to kick it over to our experts. It is my distinct pleasure to get to introduce Dr. Ka Chun Yu, who is one of our curators of space science at the museum. Dr. Yu and I have worked together on a ton of different projects and presentations, and he always has some magical things to share. So I'm going to kick it over to him. He will introduce our other expert, and he's going to help get us started. So Dr. Yu, how are you?
I'm good. How are you doing, Talia?
Doing all right. Great to be here.
Yeah, well, thank you, and thanks to everyone who are joining us tonight. Welcome to Digital Earth. As Talia mentioned, normally we'd be doing this in the planetarium, but since our current circumstances, we will be having a virtual experience. But once the museum opens up and we're able to have groups in the planetarium again, I encourage everyone to look for future iterations of this event, because it's pretty amazing to be able to be immersed in the planetarium and to experience what it might be like for astronauts to observe Earth from space. But tonight, what we will be using is some very specialized software that we would normally use in the planetarium. It's a NASA-funded project called Open Space, and we are working in collaboration with the American Museum of Natural History in New York City. And so we're really excited to be able to explore planet Earth using this software. And as Talia also mentioned, this will be a live flight, and I will be trying to keep us on target as we navigate around the globe. And I will now turn it over to my colleague, Dr. Bob Raynolds, who is a research associate in the Earth Sciences Department at the Denver Museum of Nature and Science, and he will be our main host for tonight. Bob.
Yeah, thank you, Ka Chun. Hi, everybody. So this is a little bit of an experiment for us, and you'll have to recognize that we're doing it for us. It's the first time to do a digital Earth in this format. So we will try to make all the processes work smoothly and hope to have it a seamless presentation. Our goal this evening is really to do a round the world tour. And so we're looking at a lot of distance, a lot of travel. We'll be using a flying system similar to Google Earth, which you can use on your home computers, but we'll be crossing the North American world. We'll go over to the Indonesian area, across Africa. We'll go into Europe, and then we're going to come back to Colorado. So for those of you who are based in Colorado, we're going to go on a long trip this afternoon or this evening, but we'll come right back home. And at the end, we'll be in our backyard. So first of all, this is, of course, a presentation about volcanoes, but I was thinking about how it could be presented to us, to our audience, to you guys. And it's really all about people. You know, we talk about volcanoes, but it's we who are looking at the volcanoes and thinking about them. So I wanted just to give a shout out, of course, to Talia and also to Kim, who's in the background there at the museum, that are helping to make this all happen. Of course, Ka Chun is our pilot. He's going to be leading us around the world. But I want to go back in my own history, and I first got acquainted with volcanoes back in about 1960 in Central America. We were living in El Salvador, and my parents heard that there was a volcano erupting in Guatemala, and they put us all little kids, in the car, and we drove from El Salvador to near Guatemala City to see Pacaya erupting. And so I saw that when I was probably 6 or 8 years old. And then as I went to college, to university, I was at Dartmouth College, and I had wonderful professors who were keenly interested in volcanoes. Dick Stoiber, Bob Decker, wonderful, wonderful people. They introduced me to many volcanoes and concepts about volcanoes. And then I had office mates while I was in grad school. Chris Newhall studied volcanoes. My classmate Stan Williams studied volcanoes. And here in Denver, I've been working with a fellow, Tom Cassadeval, who's also studying volcanoes. So it's a very personal thing for me. I build my understanding of volcanoes through collaboration with all of my colleagues and my mentors. And then, of course, this evening, it's really all about you, the audience. So if you guys have questions, type them into the chat, and Talia will she does a wonderful job of integrating people's thoughts, and she'll relay them to us. So our intention, again, is to have about an hour-long presentation here where we'll go around the world, ending up in Colorado, and then we hope to have 10 or 15 minutes for questions and answers after we get back. So I'm going to start out with a PowerPoint, and this involves screen sharing, which is a complicated mission for me, but I'm going to try to do it.
While you get that screen share up, I will say I forgot to mention which volcano it was in the background. We have several folks in the chat saying, wait, you didn't tell us what it was. This is Mount Rainier. So congratulations to the several of you who did get it, but there were some great guesses in there as well. All right, I'll go away now.
Okay, so I've got something in front of my PowerPoint. Talia, do you see my PowerPoint nicely?
I do not see it just yet. We might need to have you practice or try sharing your screen again. So if you have started, you might want to stop and then start again.
Is that other button? How's that?
There we go. Perfect.
It's the double button. So the question is, the first thing, again, before we get launched, I want to just mention that there are about 1,400, around 1,400 volcanoes on the surface of the Earth. And that's a pretty tricky number to come up with because there's a heck of a lot of volcanoes that are underwater and we don't know they're there. So if you ask me really how many volcanoes are there, there's many, many volcanoes, most of which perhaps we don't even know about because they're underneath the ocean. But we know about over 1,400 volcanoes on the surface of the Earth, and almost all of them are near plate boundaries. If you're thinking about the Earth's surface being made up of these semi-rigid plates, at the boundaries of those plates are where we find almost all of the volcanoes. Some of you will have heard about the Ring of Fire, which surrounds the Pacific Ocean, and there's a whole series of plate boundaries and volcanic chains along the Pacific. We're going to see one in just a few minutes, and we're not going to tell you right where we are when we launch, so you guys will have to figure out where we are. It's going to be a first question. The next thing I'm going to show you, though, is is a sketch. Let's see if I can get this to work. Bear with me. I'm there. So this is a cross-sectional view showing, again, the basic plate tectonic model that we believe is controlling the movement of plates on the surface of the Earth. And you'll see here on the left-hand side an ocean. It's sort of a mid-ocean ridge area where things are pulling apart. And then you'll see a place on the right where things are pushing together. We call it a subduction zone, where things are pushing together. And the vast majority of the Earth's volcanoes form in either places where there's extension going on, where things are being pulled apart. And that's because you're releasing the pressure, allowing the material that's deep in the upper mantle and the lower crust to rise up. So that's in places where you're pulling it apart. And then in places where you're pushing things together, where you've got compression and you're pushing things together, you're actually dragging down fluids, literally water and minerals that have water in them. And you're taking that material down into the ground, and it's releasing the vapors, essentially allowing the material to melt and to rise up. So there's volcanoes associated with extension, and there's volcanoes associated with places where you've got fluids being taken down into the earth through compression. So that's the basic framework. And you'll hear me again and again emphasize in the course of the evening that volcanoes are mysterious to us. We don't know everything about volcanoes, but we're learning a lot. And science is helping us to better understand the behavior of volcanoes and ultimately to predict their behavior and predict their eruptions. I've often been asked by my friends why people are interested in volcanoes. And I liken it back to the dinosaur story. The dinosaurs are some of the young people's best friends. And we always wonder why that is. And people say, well, it's because they're very big and they're very scary and dangerous and they're extinct. So what's not to love about a dinosaur? Well, a volcano is very big and very scary, potentially very dangerous. And many of them are dormant. They're not extinct. They're just sleeping. So in the course of this evening, we'll talk about when volcanoes wake up and what happens. And now I will stop sharing my screen and see if we can get ourselves to Ka Chun's view. I'm assuming we're moving towards having Ka Chun be full screen.
Yes, I'm going to go ahead and spotlight his video.
There we
so
go.
everyone should see his video now. And what are we looking at the moment?
So that's a mystery. So Ka Chun is flying, and we are flying over a very volcanic rich area. This area is home to 52 active volcanoes, which is somewhere on the order of 6% of the world's volcanoes. And it's a mysterious place, not very often seen because it's often shrouded in fog. And in fact, to give you a clue for you Colorado people, our 10th Mountain Division troops went up here and they were caught in a terrible weather condition, and there was all kinds of confusion. So that might be a clue to where we are. It's
if you
a long.
would like a list of guesses, we certainly have a lot coming in. Would you like me to share what some of them are?
Does some begin with an A?
Yes, we have many folks who are guessing that we are in fact looking at the Aleutian Islands. And are they correct?
Exactly right. You're looking at the Aleutians. We're flying in towards Alaska mainland, coming up through the Aleutian chain, which is a huge chain of active volcanoes. If we were to start in Denver, the length of this chain of volcanoes would take us all the way to Havana, Cuba. So it's a vast chain with over 50 volcanoes that are active and many, many more that are potentially active right now that are seemingly extinct. The reason I'm bringing you this way is because we're flying along the path that an airplane was flying back in, it was back in 1989. There was a 747, a KLM flight that came in, was flying right over this part of the Aleutians. And suddenly they hit a cloud of volcanic dust that was coming from Mount Redoubt that is just up ahead. And the 747 engines sucked in that volcanic ash, and it caused them all to flame out. So all four engines on this behemoth 747 stopped functioning, and the electrical system stopped. They went to backup power, but it must have been pretty quiet in that airplane. And that airplane proceeded to fall 13,000 feet over a period of 8 minutes. You can picture yourself in an airplane, suddenly goes quiet, and you're falling, the drinks are coming up off your table, you're falling for 8 minutes, and the pilots were desperately trying to restart the engines. And thank goodness, just before they got to the bottom, they started 2 of the engines back up again, and they're able to safely land in Anchorage. So you're looking right now at Mount Redoubt volcano. It's a volcano that has had multiple eruptions. And this issue about the health and safety of flying aircraft is one of the critical reasons why we monitor volcanoes. And that's a worldwide phenomenon. We might mention that a little bit later on in the talk. We're going to back out a little bit here. You're going to see Cook Inlet, and we're going to go right over the top of Anchorage. But we're going to head over to the Cascade volcanoes of Western United States. And again, we're just going to zoom our way down along here along the west coast of Canada. We're passing Juneau, Alaska. And we're heading near Vancouver, and we're going to be heading in towards Mount St. Helens. Now, Mount St. Helens is famous for many of you because many of you will remember the eruption that took place in 1980. I know that some of us weren't yet born, but I was a grad student in 1980, and it was tremendously exciting. 18th of May, 1980 is a date that I remember very well. My professor, Dick Stoiber, was tremendously excited. He grabbed a couple of his students, and they went out to study the volcano. And it's pretty interesting because that volcanic eruption, which took place in 1980, was really the foundation for a lot of volcano research in the United States. And a lot of my colleagues and friends who have studied volcanoes have told me that they got their impetus to do that through the understanding of the eruption of Mount St. Helens. It also provided a lot of funding for research, and a series of volcano observatories were put together in the United States, largely in part as a result of the eruption of Mount St. Helens. That volcanic eruption was an astonishingly huge event for us in the United States, but it wasn't completely unexpected. In the days before the eruption, we're coming up on Mount St. Helens now. You can see the crater sort of blown out. We're coming right up the side where you'll see Spirit Lake in the foreground, and then the great open maw of the mountain that used to be a beautiful symmetrical cone. But that side of it, the northeast side, was bulging in the early spring of 1980. And eventually, towards the latter part of May, it was bulging at 5 feet per day. The side of the volcano was stretching out 5 feet per day. And in retrospect, it's not too surprising that something had to give. At the time, people knew it was dangerous, but we didn't know how dangerous it was. And it exploded catastrophically, and it killed quite a few people. Not as many as people had been evacuated, but people were killed by this eruption, and in excess of 50 people, actually. But it left a completely changed landscape. This whole crater was formed, and it blew down the forests that were down below the mountain, and it scattered ash all the way across, even to Colorado. There were people in Denver who on the morning after could put their finger on their windscreens of the cars and see the volcanic ash from Mount St. Helens. Here you're inside the crater of the volcano. You're actually gazing at the resurgent dome. There's a dome of material that's growing in there right now. And Mount St. Helens hasn't finished erupting. It's being monitored very closely. We monitor it through looking for earthquake activity, and we also monitor it for tilting. And they fly infrared cameras over it. There's all kinds of research going on around Mount St. Helens, but it is likely to erupt again at some point in the future.
If I may, real fast, we do have several comments from folks who are sharing their experiences of where they were on the day it erupted, including Peter, who says he was actually on a plane out of Seattle when the eruption occurred and has pictures from the air. My parents have told me before about when they were living in Albuquerque, being able to see ash on their windscreen. So thanks for sharing all those stories, everybody. We love hearing those, so keep them coming.
And it's an interesting story too, Talia, because in the time that's intervened since the eruption in 1980, which is now, I guess, close to 40 years, there's been considerable regrowth. The trees have come back. I was doing a little bit of background before this talk, and some of the trees are 70 feet tall. They planted, some of them were planted, but they planted small trees in some of the blowout area, and those trees are now 70 feet tall. So the earth has the capacity to heal, and the soils around the volcano are very fertile. We'll hear that again and again on this evening's talk. And so these mountains are dangerous. They explode episodically, and then the landscape heals. So we're going to now drop down a little bit just across the main Cascades here. We're going to come down into some of this dry country in western or central Washington state. And there's a special treat here for my friends who are paleontologists. We're looking at now at lava flows that mantle this ground. These lava flows are about 15 to 18 million years old, so that's a long time ago. But one of the lava flows was flowing across the landscape, and there was an innocent little rhinoceros that was munching flowers down by a small pond. And the rhinoceros was munching flowers, and he was very powerful and didn't need to pay attention to anything that was going on around him because he was rhinoceros. But behind him, there was a lava flow that was flowing, and he disdained it because he was rhinoceros. And he was munching on his flowers down by the little pond. And that lava flow encircled him completely and eventually engulfed him completely. And he was brought up inside the lava flow. And usually we would think of him as being cooked to a cinder, but that was not the case because he was full of these tender flowers and there was some moist ground around. And the rhinoceros was engulfed in the basalt lava, and he plumped out like a raisin in a cake. And he's now right next to this place here, which is called Blue Lake. And again, the human side of the story, I went to visit this rhinoceros with my children when they were young, about 8 and 10 years old, more or less. And you had to rent a boat, and you rented a boat in a marina, and you had to paddle across this lake to get to where the rhinoceros is. And the children were somewhat skeptical about this operation, especially as the paddling was difficult because one child was bigger than the other, so the boat had a tendency to go in a little bit of a circle. But we eventually got across the lake, and there's a cliff, and you have to climb up the cliff, and there's a hole in the side of the cliff, and you go in through that hole, and it turns out that it's a rear entry rhino, and you go in through the back end, and you're wrapped in rhino. You can reach around, and you've got a foot here and another foot there, and then you've got a nose over here, and you've got a belly button. When they first got there, there were bones in the bottom of this little cave. Today, the bones are in a museum in Berkeley, but you can still go visit the rhinoceros. So that's a story about a fossil in a lava flow for a volcano. That's to give my paleontology friends a little hello. Now we're going to continue our travels, though. We've got a long way to go this evening. We're going to scoot over a little bit to the east, and we're going to get to a supervolcano. It's sort of a bit of a jargon word, but you can all imagine if we're heading for a supervolcano, it's not too far away from here. Many of you will have visited it, and we just want to show you where it is and what it looks like from space or from above. And you might guess we're going to Yellowstone, which is one of the biggest volcanic centers in the world, and it's located in northwestern Wyoming. We're going to be zooming in to some of the thermal areas in Yellowstone, and let's see what's coming. Sort of, we've got to go up a little bit. We've got to maybe step out a little bit. We will find Yellowstone. We don't have the joy of a pointer. I think we're too far north. Yeah, there we go. It's down.
We did have a lot of folks wondering if we were going to be talking about Yellowstone tonight. So here it is.
We will. We've been to the right. So in the planetarium we have pointers, and we got to step out a teeny bit more and go to the right. We're not quite there yet. And if you back out a teensy scotch, there you go. So the navigation, of course, is always a little tricky here. And Yellowstone, you can see Yellowstone Lake very nicely. The caldera, if you introduce a term, is a great big crater collapse. We'll see a couple more examples. But the lake sits in the caldera, and the outline of the caldera is pretty difficult to see, partly because it's been eroded. It's pretty old, and also partly because it's forested, heavily vegetated. The Yellowstone area has had 3 huge eruptions. One of them is back at about 2.1 million years. Another one was about 1.3 million years. And the most recent one was about 600,000 years ago. And if you're doing the arithmetic in your head, it seems like about every 600,000 years, there's an eruption at the Yellowstone supervolcano. And the last one was about 600,000 years ago. So we ran a field trip from the Denver Museum a few years ago, and we called it, we said, you have to go and see Yellowstone before Yellowstone comes to see you. So here we're looking at some of the scenery around Yellowstone. The white ground is the bleached areas associated with the thermal areas. There's geysers and mud pots and all kinds of things. But we're going to zoom in towards one of the most beautiful spots in Yellowstone, and it's called the Grand Prismatic Spring. And many of you will have been there. It's really an iconic feature in the Yellowstone system. Again, the hot waters here are coming up because there's a magma chamber only a few kilometers underground, not very far underground. There's a big body of magma, and it's causing hot waters to circulate. And this is the largest hot spring in North America. And it's a beautiful color. As you get there, you'll see the wonderful colors in the water, the blues and greens, and then these very odd yellows and oranges along the edges of the spring. And a lot of those colors are made by bacteria and other organisms that are called extremophiles. They love extreme things. I see a question about how deep is it? It's not very deep. I think I saw somewhere it's about 200 feet deep. It's about 350 feet across, just for a sense of scale. And you can walk around on a boardwalk and you can smell the sulfur. I wish we had smell-orama on this thing. That's something, Talia and Kim, if you guys could get smell-orama so we could smell some sulfur, we could have a little squirt of sulfur come out of the screen. So that might be useful.
I will talk to our tech team about that tomorrow.
But here you see, as we back out, I just wanted you to see those bleached areas. And as you've driven to Yellowstone, some of you have been to Old Faithful and the Norris Geyser Basin, some of those other features. They're the areas that are, we call them hydrothermally active. They're areas where hot springs are actively cooking the ground today. But we've got more places to go and things to see. So we're going to head west. We're going to leave the mainland of North America, but we're going to go to a state that is a volcano. And many of you can imagine which state is a volcano. And you don't need a hint for this one, I hope. So we're going to head down into Hawaii. And Ka Chun and I had long discussions about what to show in Hawaii. There's so many things to see. And of course, Ka Chun wanted to look at the telescopes up on the top of the volcano. But I said, well, we don't really have time to go look at telescopes. We're supposed to be looking at lava flows. And so we're going to recognize that there's the telescopes on top of Mauna Kea, which is 13,800 feet high. It's a tall mountain. And we're going to go look at the Kilauea eruption products. Now, this mountain, Hawaii, rises, of course, from the floor of the Pacific Ocean, and it's by far the largest mountain on the face of the earth. So we always think of Everest as the tallest mountain, which it is. But this mountain, the Hawaiian mainland, or the main island in Hawaii, is the biggest mountain, if you think about it, starting at the floor of the ocean and rising all the way up to 13,800 feet above sea level. So it's actually, if you take that whole expanse into consideration, it's taller than, has a higher relief than Mount Everest, if I can put it that way. Now, Hawaii is, of course, a place with a tremendous amount of volcanic activity coming out of the Kilauea volcano. We're seeing some of the Kilauea craters here. And there's been a lot of activity there recently. In fact, from 2010 to 2018, there was a lava lake in Kilauea, and the eruption actually got started about 1983 and extended all the way to 2018. And I used to talk to students when I was teaching. They'd say, "Well, isn't that volcano always active?" And I can remember when I was there in probably about 1980 or 79, and it wasn't erupting at all. And I've never seen Hawaii erupting, and my students thought that it was always erupting because in many cases it had been erupting their whole life. And that culminated in 2018, just a couple of years ago, with there was a catastrophic collapse of the central lava lake in Kilauea crater, and it somehow managed to breach its way or break its way underground, extending along a whole, they call it a rift system, but it's really a series of cracks and fissures that opened up. You're seeing them here on the right-hand side of your screen. And all that black stuff that looks like spilled ink is the lava flows. And those lava flows extended all the way down to the ocean. And there are fantastic movies and pictures of the red hot lava pouring off cliffs of Hawaii into the Pacific Ocean, and huge clouds of steam rising up. And many people see things in those steaming craters and in the steam rising from the sea. And I've got friends from Hawaii, and they say, "Oh, there's a very religious feeling about the goddess Pele." And Pele, the goddess of the Hawaiian volcanoes, can often be seen in those steam clouds. And my friends would say, "Well, if you take a picture of the steam cloud or of the ash and gases coming out of the craters, you'll often see the image of Pele, the goddess, in those pictures." And in fact, some of you might know this, but you're not supposed to take samples of the volcanic rock from the national parks. And Pele doesn't like it if you take samples of volcanic material from Hawaii. And the post office in Honolulu has an entire department full of returned rocks for people who have a pang of conscience someplace across the world, maybe in Greenwood Village. They suddenly have a pang of conscience, and they mail that sample of Hawaiian material back to the post office in Honolulu, where it's collected. So someday you can see that. So here you'll see these black lava flows that come right down to the Pacific Ocean. And you can well imagine the chaos and steam associated with the interplay between the red hot lava and the cold waters of the Pacific. Hawaii is getting bigger. This is a way that it's making land. So that island is continuing to grow. But we've got to keep moving. I'm keeping an eye on my itinerary here. And we've got to cross the Pacific Ocean. And we're going to go look for a sleeping beauty. And I'm going to ask you guys again, sort of think about where we might find a sleeping beauty on the west side of the Pacific Ocean. It's framed in cherry blossoms. So we've got a sleeping beauty framed in cherry blossoms right at this time of year. And you can all imagine, I'm seeing you guys, I can see on the chat, I can see you guys guessing correctly. We're heading to Japan, and we're going to look at Mount Fuji. And Mount Fuji is, of course, one of the iconic stratovolcanoes. It's called a stratovolcano. That's the shape of the volcano. And it's been dormant for 300 years. There hasn't been a big eruption from Mount Fuji for over 300 years. And a huge number of people, of course, live in Tokyo. We're going to see if we can come in via Tokyo here. And there's tens of millions of people living in the Tokyo area, 20 to 30 million people living in the region. So it's one of the more densely populated places in the world. And of course, these people are living on a very nice harbor. You'll see that they built out the land right into the harbor. We'll see that here in a moment. And it's not unlike some other big volcanoes like Mount Rainier, which is near Seattle, or Mount Popocatépetl, which is near Mexico City and Puebla down in Mexico. And these big volcanoes have been sitting there for, of course, geologic time. And the people have been moving ever closer and becoming more dense. So here you can see how they've actually built the land out into the Tokyo harbor. this is constructed real estate. Somebody got the good idea of selling the water and then filling it in and monetizing it. So we've done the same thing in Manhattan and in San Francisco, as many of you know. So huge numbers of people live here in this giant metropolis of Tokyo and surrounding areas. And over on the horizon, now coming into view, is this beautiful sleeping giant of Mount Fuji. And you can see it's got this wonderful symmetrical shape. It looks a lot like Mount St. Helens looked before the eruption, actually. So we're going to go a little bit closer to Mount Fuji, and we're going to see if we can get right up next to it. It's one of about 100 active volcanoes in Japan. So the Japanese islands, this is the big island called Honshu. The Japanese islands have over 100 volcanoes. It's, of course, very volcanically active area. And also, of course, has tremendous numbers of earthquakes. So there's a lot of concern about the danger posed by these volcanoes. And this is one of these subduction zone situations I talked about earlier, where the Pacific Ocean and the rocks in it are going, well, the Pacific plate is being subducted underneath Japan. It's carrying volatile rich or water rich minerals and muds down into the crust, and those are dewatering, and that vapor effectively is what's giving the magma the fluidity to rise. So Mount Fuji is part of the ring of fire that surrounds the entire Pacific Ocean. And it's a wonderful, iconic feature. Of course, the Japanese revere it. For the Shinto people, it's sacred. And it's a very great tradition in Japan to climb Mount Fuji. And I think if we get close enough, we'll actually see the trail going up the mountain. And you can imagine the walk up that side of that volcano. And they have special walking sticks. And I think they carve the insignia for the stations. Some of you may have walked up Mount Fuji. I unfortunately have not yet done that, but one of the things I'd love to do because I'd like to get the view from the top. And you can see pretty steep. It's not a trivial climb, but I gather that it's very wonderful to climb in the night so that you get up to the very top of the mountain right at sunrise. Everybody talks about the beauty of the sunrise from the top of Mount Fuji. And I think we can go up and look and see if we can put our noses right in the crater. Let's see if we can. The glory of this system is that we can go to places that are actually very difficult to get to. And we can look inside the crater of Mount Fuji, which is a pretty special experience here. So we're right on the crater rim, and we're looking down into the mouth of the mountain. So you're gazing into the maw of Mount Fuji. We'll see if we can find a few other mountains like this to look into before the end of the evening. So Ka Chun, we can't linger too long. We're going to have to back our way out from Mount Fuji, and we're going to go down towards Indonesia now. So we're going to stay on the Ring of Fire, but we're going to go down south of the Philippines, and we're going to go over to an area between Sumatra and Java. It's called the Sunda Straits. And some of you, again, will be able to guess the volcano that we're going to. It's a very, very famous spot right in the gap between those two islands. Sumatra is on the left and Java is on the right. And exactly right. I see somebody guessing Krakatoa. And we're going to go right down and see what's left of Krakatoa. Krakatoa, you might remember, a very famous early volcanic eruption that was very well documented. In 1883, the volcano blew itself apart, a huge eruption, one of the biggest eruptions that we've witnessed in historic times. They could hear it all the way in Perth, Australia, thousands and thousands of miles away. They heard the eruption when the island blew apart. And it's coming back to life. There's a little volcano right there in the middle. It's called the Son of Krakatoa, Anak Krakatoa. And it's growing right where Krakatoa used to be. And you can see it's a very interesting cinder cone at the dark island in the middle. It's got a crater with a lake in it. And it's got this very strange brown water flowing from its flanks. And we believe there's a big hydrothermal system, a lot like you saw in Yellowstone, circulating right at the foot of this volcano, this little cinder cone. And it's causing that reddish material, that brownish red material, to come out into what's really part of the Indian Ocean here. And the volcano is definitely active. You can see some steam coming off of it there. This volcano, like many others, has webcams on it. Unbelievable today's technology. You can sit in your living room and you can watch a webcam of Krakatoa or Anak Krakatoa, and it has frequent eruption. I did some poking around on this, and I found an article in Wired magazine from a few years back. It says that there's 150 different volcanoes being monitored by webcams. Some of them have multiple webcams on them. And the article cautioned you and said, well, some of the webcams aren't working really. But I think if any of you wanted to try this out for yourselves, if you poked around a little bit on your computer looking for volcanic webcams, just look up Google and do volcano and webcams, web CAM, and it'll pop up some examples where you can see a camera pointing at a volcano. But we're going to leave Krakatoa and we're going to head over to Africa now. And I've done a lot of work in Africa. I work on the geology of Africa. I love the geology of the Rift Valley. And when I was a student, or I guess just after I graduated from undergraduate, I was with a couple of colleagues and friends, and had the good fortune to be able to climb this next volcano that we're going to go to, which is the highest mountain in Africa. It's over 19,000 feet high. And we thought we were in pretty good shape. We thought we'd just pop up this volcano and check it out. And this is Kilimanjaro. Many so people guessing that. We're going to come down into the top of Kilimanjaro. And it's a beautiful volcano right up above the Serengeti Plains. It's got this characteristic ring of vegetation around it. And when you get there on the ground and you climb it, you realize you pass through these different ecosystems. You leave the fields down at the lowlands. You climb up through a tropical rainforest. Then you got up into a high sort of dry forest with very bizarre plants called lobelia. And then eventually you get up into the tundra. So you walk from the rainforest up into the tundra, and then you climb up onto this very steep slope. And we had crossed from Tanzania or from Kenya into Tanzania, and we decided we'd save the money. We were students, so we saved the money not getting a hotel room. We took the night bus, and we got to the border in the middle of the night, like 1 o'clock in the morning. And one of us had on short pants, and it turns out you're not allowed to wear short pants in Tanzania, at least back then. This would have been 1973 or so. And so we had to change our clothes, and they weren't too happy with us. We looked like vagabonds of some kind. So they said, well, how many days are you going to be in Tanzania? And we said, well, we just need to go climb Kilimanjaro and come right back. They said, okay, well, 5 days should do just fine. So they gave us 5-day visa to come into Tanzania. And we scooted into Tanzania. We got in the middle of the night, we got to the town of Moshi, and we put our sleeping bags out on the ground. And in the morning, we were looking for the volcano. We said, there's got to be a volcano around here somewhere. And we were sort of looking at the horizon, hoping to see a mountain. And then we realized we had to crane our necks back and look way up, because Kilimanjaro rises very high up above Moshi. And indeed, it was quite a saga. We hiked up to the top of the crater rim, and I'm choosing my word carefully. We didn't get to the actual summit, which is across the other side of the crater. We got to the top of the crater rim, and we were exhausted. And we didn't have a guide. We didn't really know quite what we were doing. And we ended up sort of sitting there exhausted, and we didn't have the right clothes. We had socks on for mittens. We didn't have anything to carry water in. It was a little bit of an adventure. But then we realized we had to turn around and scamper back, because it'd taken 3 days or something to get up to the rim. So now we had to run down the mountain, basically, which we did, to get out of Tanzania within our 5-day window. But you can see the dwindling snows up on top of Kilimanjaro. There's a lot of discussion about that. The snow is melting, the climate's warming, and Kilimanjaro is sort of a bellwether for that. You'll see less and less snow on top of Kilimanjaro as time goes on. Ka Chun, let's go on over to this big caldera that's right nearby. And I just want to show you again one of my favorite places in Tanzania, which is a big caldera. So caldera is that big collapsed ring. We talked about it at Yellowstone. Now we're going to see a really classic caldera form that's just coming into view there. We're crossing Lake Manyara. There's Lake Eyasi, I think it's called, and it's right in the top of the screen. Ka Chun coming, it's there in the top right. And we're going to just get a look at this place. It's a great big circular depression. There's a little bit of a lake in the bottom of it, but it's about 13 miles across. So from one edge of the rim to the other, about 13 miles, depending a little on where you are, 12 to 13 miles. And it's a very isolated place. Not many people live there, but lots of people go here because of the wildlife. It's a beautiful national park, a wonderful place to see wildlife. And if you go down onto the floor of this crater or caldera, you'll see all kinds of animals. There's wonderful flamingos in the lake. There's zebra, wildebeest, rhinoceros, and lions, all kinds of antelope. And surprisingly enough to me, there are abundant hippos in here. And I've long wondered how the hippos belayed themselves down those cliffs to get into the bottom of Ngorongoro caldera. And if anybody who's participating has any idea about how that might have happened, I'd certainly like to know, because you've got to picture hippo saying on belay, and then the other hippo saying, ready, and then giving climbing instructions and getting themselves down. And there had to be 2 hippos probably to make it work. And I don't know how the second hippo undid the rope and got down. I mean, it's a problem. So, but in any case, when you go to Ngorongoro, I'd encourage you to go, if you haven't been there, and ponder the presence of hippopotami on the floor of this caldera. Okay, so now having pondered the hippopotami, now we've got to keep moving, because we're going to cross the Sahara Desert. And as we cross the Sahara Desert, we're going to get distracted by a volcano, which I hope you will pardon my distraction here. But we've got the Mediterranean up on the top, and we're going to come into what's called the Tibesti Mountains here. And I've long looked at this place yearningly from space. I've looked at many satellite images of this, and now with Google Earth, we can fly there, and Ka Chun can fly there using OpenSpace here. So we're going to fly right into this thing that looks a little bit like an octopus there. You see that thing looking like an octopus? That's a volcano, and it's in the Tibesti Mountains, and it's called Tusidé. It's Mount Tusidé. And right next to Mount Tusidé, there is a little tiny crater, which we're going to go down inside. And this is a place that's hard to get to, but we can go there this afternoon or tonight. So you're going to see this little side crater. We're going to go in this little side crater, and within the little side crater, we're going to find another little crater right there. And that little crater on the top of your screen is called Dune. And the whole crater that it's in is called the Trou de Natron. A lot of people speak French around here, and there's French tourists down in there right now. It's unbelievable. If we got close enough, we'd see the French tourists. I think I see a French tourist in the middle of that inner crater. There, right there. Okay, so they're there right now. So it can be done. I think you have to take a camel. So when we get adventurous again, we might encourage the museum to consider a camel traverse of the Northern Sahara so that we can get to this beautiful crater. I see someone asking about the Rishat structure. The Rishat structure is actually thought to be a dome. It's over in Morocco. We don't have time to go there, but we might do another program that involves domes and meteor craters. So if you're interested in that, we might see Rishat, but in another visit. So I'm answering a question I saw in the chat there. But we've got to keep moving, Ka Chun, because we've got to get ourselves up to Europe. So we're going to pull ourselves out of this crater reluctantly, leave the tourists behind, and we're heading up to Italy. And you can imagine which volcano we might go to in Italy. You're right. I can sense through the ether that people are guessing we're going to a volcano that begins with a V. And we're going to cross the Mediterranean. Oh, yeah, that's true. I think Ka Chun, I got ahead of myself here. I'm sorry. Chun is all, let's back, yeah, there we go. So before we get to the volcano beginning with a V, we're going to go to one that begins with an S. And it's I just got ahead of myself. So we're going to go north of Crete. Now again, I'm teasing you guys a little bit, but we're going to go to this amazing volcano that was responsible, we think, for the end of the Minoan civilization. And this is a volcano that is coming into view. You'll start to see a circular island with a little thing in the middle of it. Again, you're going to get the feeling of a big crater or caldera, and there's a resurgent dome in the middle of this. And this is the island of Santorini or Thera. And that resurgent dome is growing in the place where there was a giant mountain that blew apart about 3,600 years ago. The thing just blew apart. And the eruption put ash all over the Mediterranean, and it wiped out the Minoan civilization, in part through the ash that fell, but also through the big tsunami. And the cities and towns that were on this island, and there's a famous one that you can visit called Akrotiri, it's thought that this might be the source of the myth of Atlantis, because this was an ancient civilization, an ancient city area that disappeared beneath the waves of the sea. And it's speculated that this is where the myth of Atlantis comes from. And certainly in the archaeological record, the event about 3,600 years ago, around 1500 BC, there's some discussion about that date, but it's a punctuation point in the archaeology of the Mediterranean. So the volcanoes and people, of course, are intimately entwined. And again, now this sets us up for going to the V volcano. So we're going to scoot past Santorini here, leave the Greek islands. These are the Greek islands. We're going to pass over Greece, and we're going to go to Italy. And when we get to near Naples, we're going to see Vesuvius rising above the city of Naples and the Bay of Naples, which is a very active volcanic area today. There's a caldera system called the Campo Figure right there in the Naples Bay. You can see this semi-subcircular view of the Naples Bay, with Vesuvius being the mountain that's just to the right or the head of the bay. And as we zoom on in, you've got to remember the history here. In 79 AD, huge eruption from Vesuvius destroyed the city of Pompeii and the city of Herculaneum down by the coast. Those are just on the right-hand side of your screen. We're going to go in and look at the volcano itself. But this interplay between volcanoes and people is one of the common themes and threads through this whole presentation. And of course, the city of Naples is sitting there today at risk because the volcano is looming above them, and Vesuvius is still active. I think we can, this is again, we might be able to sneak a look right into the maw of this volcano. Pretty unusual opportunity here. And you can look over the crater rim. There's a little spot there. Some of you will have been to that little viewpoint, but using Ka Chun's magic, we can actually get ourselves right inside, and we'll go inside the crater of Vesuvius. Still active. There are fumaroles in there, hot gases coming out. It's still moving. It's an espresso house. How could I have doubted it? There's an espresso house on the rim of the Vesuvius mountain. So all of us can eventually hope to have the opportunity to reopen Italy and to go to the espresso house and sip a little cup of espresso while we gaze into this volcanic crater. So you can see the rocks that are at angle of repose falling down into the crater floor from the rim. A very dangerous place, this place indeed. But we have to keep moving. And so we're going to now pull ourselves out of Vesuvius. We're going to pass amazing things that we don't have time to go to. We're going to go right over the top of Sicily. We're going to go right over the top of Mount Etna. We're going to go all the way across the Atlantic Ocean. We're going to cross some wonderful volcanic islands, including things like Iceland and other wonderful places that I wish we had time to go to. But I promised you that we would come home before the end of the hour. And Ka Chun's got to wake up America. There we go. And we're going to come back in towards Colorado. So I'm now sort of drawing ourselves to come home. And you might say, well, I didn't think there were volcanoes in Colorado, but there are volcanoes in Colorado. The San Juan Mountains are examples, big, huge volcanoes in the San Juan Mountains. Those are pretty old. They're around 28 million years old. Cripple Creek is a little bit younger. The volcanoes of Cripple Creek and San Juans are associated with lots of ore deposits. So there's tremendous activity of, these would be hydrothermal systems that were active in the past that precipitated metals like gold and silver. So if you think about Creed, Lake City, some of the areas in the San Juan Mountains, they're mining districts that are very, very famous. But I want to take you to the youngest volcano in Colorado. So I see people talking about Table Mountains. We're going to leave the Table Mountains, which are lava flows, but they're about 65 million years old. So I want something that's young and fresh. And we're going to come down in, we've got Glenwood Canyon sort of in there, and we're going to head to the confluence of the Eagle River and the Colorado River. And I'm going to bring you right down onto Interstate 70, and we're going to be careful not to get squashed, but the intersection of those two rivers, the Colorado River is coming in from the north. It rises from Grand Lake and Rocky Mountain National Park. It joins the Eagle River that comes from Vail and country up by the Tennessee Pass and Camp Hale. And now we're coming in. You can see the two rivers coming together and flowing out to the left. So the one from the right is the Eagle River. The one from the top is the Colorado River. The confluence happens right near a place called Dot Cerro, and it's on the interstate highway. And we're zooming in towards Dot Cerro here, and you'll see a little valley coming down from the north that has a dark stuff in it. It's a little bit to the right of center of the screen, and it comes down towards a trailer park there. Poor people in the trailer park. It comes down, and it's a lava flow, and it came right across what's today the interstate. It dammed up the river, the Eagle River, and made a lake. And you can see that lava flow right there. It's straight in the center of the scene. It's the dark material in the valley floor. And I was in there looking at the lava, and I collected this huge volcanic bomb. I wanted to show it to you guys, but I couldn't move it. It's in my greenhouse. It's the size of a giant watermelon, very heavy. It's a volcanic bomb that got squirt out of a crater, landed smack there near the trailer park. And that volcanic eruption is about 4,150 years old. And the crater is coming into view right here. There's a little dirt road track that gets up there, that crater. Here you see the crater. And this is the youngest volcanic crater in Colorado. So it's our little baby volcano, only 4,000 years old. Lots of interesting ash and scoria around there, lots of volcanic material. And this is a volcano that you can visit this weekend. You can hop in your car. This is, what is it, safe at home and in a volcano. So you can head out to see this volcano this weekend. It's within range. You drive west from Denver, you get off at the Dot Cerro exit, and you have to then make it an adventure. I'll invite you to use your tools. You might use Google Earth, you might use a mapping program, but I think that you can find it. And you can drive there in a Subaru. I probably can't get there in my Mini Cooper, but in a Subaru, you can get there. And this is a volcano for all people to see, and it's your own little volcano, and you can scoot out there and look at it this weekend if you'd like to. So I'm going to sum up just briefly. I want to just make a couple of points about the general thought of volcanoes and people. And I just want to emphasize the fact that we're learning a lot about volcanoes. Mount St. Helens taught us a lot. It instituted studies of volcanoes in North America. Many people got psyched up by it. And there's a huge amount of science associated with studying volcanoes. We use drones, we use seismometers, we use tilt meters, we use thermal scanners. We use a wonderful variety of technologies to study volcanoes. We're learning more, we're understanding more. And of course, the goal is to be able to predict how volcanoes are going to perform in the future. And as we back out from Colorado, you'll see Yellowstone right in the center, upper part of your screen. So we're not too far from the supervolcano of Yellowstone. We're not too far from the Cascade Volcanoes of the Pacific Northwest. And we here in Colorado are within range of volcanoes. And I'd like to encourage you all to learn more about volcanoes. Come to the museum, talk to us, and we'll do more programming in the future, hopefully in the Dome, and you can join us in the Dome. But I'd like to thank you all very much for participating. And I think it's almost 8 o'clock, and Talia is giving me the high sign somewhere. And and maybe we can have time for a few questions, Talia, if people are interested. We'll
We
turn it over
do
to you.
have time for a few questions. So I do, before we transition into questions, want to say a huge thank you to you, Bob, for your incredible narration and storytelling. We had so many people just saying, wow, these are the coolest stories in the chat. And I do want to give a big shout out to Ka Chun as well, because that was some expert flying. Yes, I know it's hard to sometimes find some of the very particular and hard to spot landforms that we were looking for, but you both did a tremendous job. So thank you both. Thank you to everybody who hung on. I can hear the 8 p.m. howl happening outside my window, so that means it is 8 o'clock. But I do have a few questions here that I would love to pose to both of you. If you can hang on for just a few minutes, audience, we'd love to answer some of your questions.
Talia, do we get to howl?
What's that?
Oh!
That's right. And folks, if you did not know, one of our Denver Museum of Nature and Science staff and her boyfriend were the two who started the Go Outside and Howl at 8 p.m. Facebook group. That's our Chelsea Ochoa. We love her so very much. All right. One of the most common questions that you got this evening was, how worried should we really be about the Yellowstone supervolcano?
Well, of course, that's an interesting question. And I think that I look at it as an opportunity to learn more. I went to Yellowstone again with a museum group. We went to the Norris Geyser Basin, and it was bulging when we were there. And people said, well, there's a magma injection event happening. And we were interested. We were mildly concerned. But I think that when Yellowstone gets ready to erupt, I think there'll be a lot of precursor activity. In other words, we'll see things perking up. So honestly, I think that you've got other concerns in your lives than to worry about Yellowstone. But if you take the whole world and say in your lifetime, if you think about Asia and Central America, Africa, Indonesia, I think that it's probable that in the lifespan of young people today, there will be a volcanic eruption somewhere that will cause a lot of loss of life. That's a likelihood. But I think that here sitting in Denver, you're pretty safe.
It's just one of the things that we sort of have to sit with, right? As people who love nature, you have to respect the awesome and sometimes terrifying power of the natural world. Awesome. Some questions, or a lot of viewers actually wondered something like, is a volcano ever completely dead? You know, we hear about dormant volcanoes. Do volcanoes ever completely go kaput, or is there a chance that even those long dormant volcanoes could come back?
Well, you know, that's a good question. And I was talking to a volcanologist, Chris Nye, who's a friend of my sister's, and he was an Aleutian specialist. So I was getting some Aleutian background. And he reminded me, he says, don't get too cocky about what you know about volcanoes. He says that some cases, well-known cases, of something that was thought to be completely dead suddenly erupting. And you all might remember the famous volcano in Mexico that erupted in a farmer's cornfield. That's Paricutin. That erupted in about 1948 or 49. And there was nothing there. And suddenly there was a volcano. And I've been to the church that was engulfed by the lava flows. And the lava flows are thick all around it. And the church sits there amidst the flows, and they still light candles on the altar.
That's fascinating. Oh my gosh. I have such wanderlust and travel. I have a travel bug after this program. I want to go see all of this. As soon as it's safe, I'm going to be out there and going for it again. I'm going to ask you 2 more questions, and then I have some final words that I will leave us on, and then it will be time for us to wrap up. A lot of folks also wondered, I just lost it. What is the difference between a crater and a caldera? We heard both of those words a lot this evening, and I think some folks are wondering.
Yeah, no, that again, interesting. And it's difficult to not get too overwhelmed by jargon. So a caldera is really a giant crater. And we tend to think about caldera eruptions as being particularly catastrophic. And there's several examples of these very large craters. Yellowstone is maybe the most famous for us in the United States. So the volcanology community thinks about the size of the craters and the size of the calderas on sort of a continuum. And there's little tiny cinder cones you can sort of put in your lap. And then there's these giant things that are tens of miles across. And those giant things are associated with these massive eruptions that produce huge amounts of material that eventually get called supervolcanoes. And there's a scale that's sort of it's like the Richter scale. It's a logarithmic scale, and the super big volcanoes are supervolcanoes and often associated with calderas. So It's a caldera is a giant crater.
Okay. Oh, good to know. It's a good distinction. And it looks like Ka Chun is showing us Yellowstone again. Very good. I have one more question, and I'm actually going to direct this one, I think, to Ka Chun. Maybe you can answer this one. A lot of folks are wondering, is open space software available to the public? How can people have adventures like this on their own? And maybe if open space isn't something that the average Joe could just download, is there another program that you could suggest?
Actually, it turns out open space is available to the public, and you can, if you go to your web browser and go to openspaceproject.com, you'll actually find a website where you can download the software. And the software is still under development by folks at the American Museum of Natural History, along with their collaborators at universities around the world, actually. But it is currently funded by NASA, and so it's not only great for exploring the Earth, but you can actually use it to explore the entire universe, our solar system on outwards. And so, but because it is beta software, it's not very easy to use. But if you feel like you're computer savvy, definitely go to openspaceproject.com and download and install the software. And for those of us who may not want to be trying out experimental software, as Bob said earlier, one thing that you can do is to use Google Earth. That's something that's free that you can download, and you can explore the Earth at super high detail, like what we're doing tonight.
Very good. Well, that's your assignment for this evening and beyond, folks. First, well, you have a couple things. You got to go to Ductero. You got to go up to the mountains and check out Colorado's crater. Do so safely and with your masks on, of course, please. You have to look up open space or Google Earth and start to have some of these adventures all your own. And of course, I got to say, you got to keep showing up for these Wednesday night events because we love having you. Thank you all for joining us this evening. Thank you to our experts. And I will leave you with one especially special comment from the chat that I would like to highlight. PLB from Fort Collins has written us a haiku about tonight's presentation, and I would like to share that with you all right now. That haiku is, hippos on belay populate the caldera, tonight mystery. Well done, everybody. Thank you so much for tuning in. Thank you to Bob and Ka Chun. It was great to get to talk to you. We're going to go ahead and end the meeting now. Have a wonderful night, everyone. Stay healthy, stay connected, and stay curious. We'll see you next time. Bye, everybody.
Yep. Bye, everybody.